We are going to look at the basic things associated with a polynomial function. On Tuesday, we did the arithmetic with a polynomial function, adding, subtracting, multiplying, dividing. Today, we're going to get into more of the nuts and bolts of what a function is and does. So, a lot of the stuff that I just put the brace behind is just the general definition. So let me simplify it and tell you what you ultimately need to know from it. So, polynomial can only have one variable. It's only allowed to have one variable. So if it has more than one variable, it's not a polynomial. Key things that you need to know. Polynomials always have to be in standard form. What is standard form? When the exponents are in descending order. So that means your polynomial starts with the biggest exponent and then works its way down. So your polynomial should always be in standard form. Two other key things about a polynomial. The degree is the biggest exponent. And the coefficient of the first term is called the leading coefficient. So the leading coefficient is the number in front of the variable with the biggest exponent. So that's what the leading coefficient is. So you'll have to know how to identify the degree, have to identify leading coefficient, and then telling whether something is a polynomial. So basic criteria, polynomial can only have one variable. They have to be separated by plus or minus signs. All the exponents are whole numbers. So no negatives, no fractions, and all the coefficients are real numbers. So it means no imaginary numbers and things like that. So before we do a couple examples, does anyone have any questions on the criteria that a polynomial has to meet? Not hearing any, not seeing any, so let's do a couple of examples. So for each of these three examples, we're going to identify the degree. We're going to identify the leading coefficient. And we're going to answer, is it a polynomial? So that's more or less a yes or no. So if it's yes, we'll simply put yes. If it's no, then we have to tell why. So if it's a yes, put yes. If it's a no, we have to give the reason why. So with example 1, here's our polynomial, 7z to the third minus 4z squared plus z. And we're looking for, so the degree is the biggest exponent, so that's 3. The leading coefficient is the number in front of the variable with the biggest exponent, so that's 7. Now, is it a polynomial? Let's make sure it meets the criteria. Does it have one variable? Yes. Separated by plus or minus signs? Yes. All the exponents are whole numbers, 3, 2, and 1. Yes. all the coefficients are real numbers. 7, -4, 1. That's a yes. And the answer is yes. So taking care of that particular problem. Questions, example 1. All right, not seeing or hearing any, so we can move on to example 2. Remember, if you have questions, please make sure you ask. Don't wait until after school to ask the question. You can ask right now. Example 2, we're going to do the exact same thing. Degree, leading coefficient, and is it a polynomial? So degree, I'm looking for the biggest exponent. So that's 3. Leading coefficient is the number in front of the variable with the biggest exponent. So my question for you is that a polynomial? It's not. Why? There's more than one variable. So right there is how it failed. So the answer is no, because more than one variable. So if the answer is no, don't just put no, tell me why. Don't just put no, tell me why it's no. Questions, example 2. All right, sounds good. So let's take a quick 45 seconds. Do example 3. Do it yourself before we do it together. Degree, leading coefficient, is it a polynomial? Take a moment to look at it yourself before we do it together. We're already about 15 seconds in. All right, we're about ready to knock this one on out. So for the degree, I'm going to say it's 6. Leading coefficient, I'm going to say is -8. Is that a polynomial? Why not? One of the exponents is negative. So that part right there causes the whole problem to be a no. Let's see, I don't want the highlighter anymore. I want my red pen. No, because of the negative exponent. So yes, if you put no, you need to be prepared to tell why. Any questions before we continue? All right, let's go to the second part. So the second part is evaluating, which evaluating is more so algebra 1 than it is anything else. Evaluating means take the number or the variable or the expression, plug it into the problem, and simplify it. So we'll do one with numbers and we'll do one with variables. Evaluate f of -5 with that as your function. So the -5 in parentheses means you plug in the -5. Plug in the -5 everywhere you see x. Where you see x, you plug in -5. And then we do our computation. So this is nothing more than order of operations. So 3 times -125, 5 times 25, 9 times -5 minus 4. -375 minus 125 minus 45 minus 4. So you should get -549. So if it's a number, it's pretty much plug and chug. Number is plug and chug. If it's variables, then you got to be a little bit more careful because you're going to also be simplifying. Some distributive property, maybe a little FOIL, combining like terms, things along those lines. So example 2. Here's the function that you're working with. You're being asked to find b of 2x minus 1 minus 3 times b of x. So my advice is to read it first and then start attacking it. B of 2x minus 1 means take 2x minus 1 and plug it into the problem. So everywhere you see m, we're going to put in 2x minus 1. Minus 3 times, now take x and plug it into the same function. Now we've plugged everything in. Any questions before we continue? Because at this point, now it's a simplifying problem. This. So this part says 3, which I have, times b of x. So the original variable was m. They're saying plug in an x. So you need to take x and plug it in everywhere you see the letter m. That's where this part came from. So m is what you started with. So that means if I put something else there, I need to plug it in. No one ever said it couldn't be a different letter. You plug in whatever your heart desires. So which 2x minus 1? So this is so 2x minus 1 there is the same thing as saying m is equal to 2x minus 1. That's what that part means. And then for this part, m is equal to x. So there's no rule that says that it can't equal another variable. Yep. We made it two different things. Doing this is no different than saying m of 6 minus m of 4. I could make, let's see, I did that part wrong. B of 6 minus B of 4. I can make m two different numbers. How come I can't make it two different variables? No. That's if they are assigned that way. So, like I said, now y'all are going into advanced level mathematics. A variable can be another variable if it's going to be assigned that way. So now you really have to pay attention to how things are arranged and how things are assigned. So now we're getting into that advanced level mathematics. But now that we have everything plugged in, we can go ahead and solve it. So 2x minus 1 squared. Remember, if something is squared, you need to write it twice. You should not just be distributing the squared in. That's an algebra 1 mistake. We're in advanced level mathematics. So 2x minus 1 times 2x minus 1, 4x squared minus 4x plus 1. That's simply doing the FOIL and combining like terms. Now we distribute. So when you distribute 8x squared minus 8x plus 2 plus 2x minus 1 minus 1 minus 6x squared minus 3x plus 3. Then all that's left is to combine like terms. 8x squared minus 6x squared is 2x squared. Negative 8, positive 2x, negative 3x, negative 8, negative 6, negative 9. 2 minus 1 and plus 3 plus 3. That's your simplified answer. So before we go on, any questions on examples 1 or 2? So one thing to know, a variable can be set equal to a number. It can be set equal to another variable. It depends on what the problem is asking you to do. That's going to show up a lot more for those of you who are going up the pre-calc, going up the calculus. We do a lot more with making variables other variables at those stages. I'm talking about my engineering folks. Engineering, med school, some levels of business, things of that nature. So, in a moment, we're going to look at graphs, but go ahead and take 90 seconds, stand up, stretch, take a breather, and in 90 seconds, we're going to look at. All right, got my recorder back on, so let's go ahead and push on. So now we're going to look at the basic parts of graphs. So first thing with graphs is looking at their general shape. So we're looking at the general shape of a graph. So at first we look at degree. So the degree will tell you what type of graph you should expect. So for example, if your degree is 0, then you're going to have a constant function. Constant function is a function with no variables. So y equals 3 is an example of a constant function. If your degree is 1, then you have a linear function. So we're used to linear functions. That's our slope-intercept form and all that good stuff. If your degree is 2, you have a quadratic function. Dealt with quadratic functions a time or 2 before. Degree of 3, cubic. Degree 4, quartic. Degree 5, quintic. There are probably names for 6, 7, 8, all the way up. We're not going to get into, or we're really worried about the names going that far. However, the degree does tell you something else. The degree tells you the maximum number of times the graph can intersect the x-axis. So the degree tells you the number of times the graph can touch the x-axis. So if the degree is 0, it can never touch the x-axis. If the degree is 1, that means it can touch the x-axis 1 time. If the degree is 2, then that means it can touch the x-axis up to 2 times. 3 times. 4 times. And so on. So every time it touches the x-axis, it is an x-intercept, but we have another name for it. It is called a 0. Why is it called a 0? Because that is the point where the function will equal 0. where the y value will equal 0. So if it touches the x-axis, it's called a 0. Regardless of what type of graph you have. Any questions so far? So let's look at this bottom part. So this bottom part will take a little bit of this. Again, side note, those people who like the hard paper copies of the notes, make sure you check by door 12. Those paper copies will be down there. I'll put these notes in there and rerun them. That way you don't have to recopy these. So I'll rerun those packets so that this is in there. So when we look at a polynomial function, there's another thing that we have to take care of, and we have to look at. And that is called the end behavior. So end behavior, end means what is it doing at the end? Behavior, what is it doing? So end behavior is asking you, what is the graph doing when it goes to positive infinity or negative infinity? So in English, this is what it means. If you look at the left-hand side of the graph, as x gets smaller, what is the graph doing? Is it going up? Is it going down? What is it doing? Then, when you look at the right-hand side of the graph, as x gets bigger, what is the graph doing? Is it going up, going down, so on and so forth? The answers to those two questions is based off of the degree, and it's based off of the leading coefficient. The degree and the leading coefficient will tell you what is happening. So if you look at your screen, notice that there are 4 different diagrams. These are the 4 possibilities that exist. So, a few things just for clarification. First thing, f of x is the same thing as y. F of x and y mean the same thing. Additionally, on the x-axis, if you're going to the left, that means you're going to negative infinity. If you're going to the right, then you're going to positive infinity. If you're going up, that's positive infinity. If you go down forever and ever and ever, that's negative infinity. So knowing those directionalities is important when we do end behavior. So we're going to look at each of the 4 types. So again, this is the first time most of you have probably studied end behavior before. But if you're going to pre-calculus or calculus, you're going to need to know how to work with end behavior, because you're going to be studying how a function works, how a function behaves. So you got to know how the graph behaves. So let's start with the first diagram. First diagram, so this is what happens when the degree is even and the leading coefficient is positive. So an example of this, f of x equals x squared. The degree is even and the leading coefficient is positive. So let's start off with the left. So as x gets smaller, what is that part of the graph doing? Is it pointing up or down? Don't make that harder than what it is. It's pointing up. So if you're pointing up, you're going to positive infinity. So on the left-hand side, as x goes to negative infinity, f of x is going to positive infinity. Why? Because it's pointing up. Now let's look at the right-hand side of the graph. There's the right-hand side of the graph. What is it doing? Is it pointing up or down? Pointing up. So that means as x goes to positive infinity, f of x is going to positive infinity. That is your end behavior. So these two statements represent your end behavior. Do you have to write it like that? Yes. If you just put up and down, it's going to get marked wrong. So yes, we're going to use the mathematical language. Any questions before we continue? All right, and let's keep going. So we're going to do the one below it. So we're going to keep the degree even, but now we're going to make the leading coefficient negative. So an example of that, y equals negative 2, x to the 4. Degree is even, it's positive. I mean, it's the degree is even and the leading coefficient is negative. What is happening to both parts of the graph? They're both pointing down. So that means on the left-hand side, as x goes to negative infinity, f of x is also going to negative infinity. On the right-hand side, as x goes to positive infinity, f of x is also going to be negative infinity. Think of the symbols like this. As x goes to the left, the graph is going down. Negative infinity is pointing down. As x goes to the right, f of x is still pointing down. Y is going down. For the top part, you can do the same way. Think of it the same way. As x goes to the left, the graph is pointing up. As x goes to the right, the graph is pointing up. Any questions before we do the other two parts? It's not as difficult as you might think it is, but you do need to know what the symbols mean. Once you know what they mean, it's probably fairly easy. So let's do the other two parts. Degree is odd and it's positive. So example of that, f of x equals x to the third power. So on the left-hand side, where is the graph pointing? Left-hand side is pointing down. So that means as x goes to negative infinity, f of x is going to negative infinity. What's happening on the right-hand side? It's pointing up. So as x goes to the left, the graph is pointing down. As x goes to the right, the graph is pointing up. Simple enough. Now let's do the last one. Degree is odd, the leading coefficient is negative. So f of x equals negative 3x to the fifth. That's an example of what it could be. What's happening on the left-hand side? It's going up. So as x goes to negative infinity, the function goes to positive infinity. What about on the right-hand side? What's the graph doing? It's pointing downward. So as x goes farther to the left, the graph is just going to keep going up. If x goes to the right, the graph is going down. Any questions on the four types? These are the only four types. So that means it's got to fall in one of these four categories. So what we're going to do with the remaining bit of time is we're going to practice looking at a graph, identifying the end behavior, identifying what kind of degree it could be, and identifying how many zeros does it have. And that's how we're going to finish today. So suppose I gave you a graph. Now we're going to do example 1 as a model. So for each graph, first thing, describe the end behavior. end behavior is answering the two questions. As x goes to negative infinity, what is the graph doing? As x goes to positive infinity, what is the graph doing? So, as x goes to the left, what is that doing? It's pointing up. Since it's pointing up, that's positive infinity. Up means positive infinity. Now we do the same thing on the right-hand side. What is it doing on the right-hand side? Pointing up. So that's also positive infinity. So there's the end behavior. Any questions before we continue? So, for the degree. So based off of this graph, we have to ask ourselves, would the degree be odd or even? So here's our graph. Which one of these four types does it match up with? The evens or the odds? Matches up with an even graph. There it is. Last part, state the number of real zeros. Number of real zeros. So this part is the easy part. The real zeros means go to the x-axis. Tell me how many times does the graph touch the x-axis? How many times does that graph touch the x-axis? 0. There you go, 0. So you just answered all three questions. What is the graph doing? What is the degree? And how many times does the graph touch the x-axis? Any questions before we do example 2? All right, let's do example 2. Example 2, start the same way, end behavior. So, if you look at the graph on the left-hand side, what is it doing? Pointing down. Down means what? Down means negative infinity. Now we go on the right-hand side. What is the graph doing? Going up in positive infinity. Do not just put up and down. That is the surefire way to get it marked wrong. Use the mathematical symbol. If you don't know how to draw an infinity symbol, put two circles next to each other. Or draw an 8 sideways. Don't worry, I'm not going to grade you on how cute you can draw an infinity symbol. If I was going to grade you on how cute some of you all look, I would have never graduated from kindergarten. So you will be just fine. So we've got the end behavior. So I have one part pointing down and the other part pointing up. That's odd. So now I need the number of real zeros. So how many times does that graph touch the x-axis? 3 times. Uno, dos, tres. There we go. Problem good. Yeah, for some of you, it's not as hard as you think it might be. Not as hard as you think it might be. You just have to pay attention to what you're doing. So let's get these last 2 out the way. End behavior. So if you're on the left-hand side, what is the graph doing? It's going up, and up means what? Positive infinity. If we go on the right-hand side, what is the graph doing? Bingo. What's the degree? Is it odd or even? That's odd. And how many real zeros do we have? 3. 1, 2. Let's do the last one. So, if x goes to negative infinity, what is the graph doing on the left-hand side? And as x is on the right-hand side, what is the graph doing? So there's your end behavior. Would the degree be odd or even? And how many real zeros do you have? Yeah, it's not hard. You just have to know what everything meant first. And if it challenged you and it made your brain hurt a little bit and you had to struggle a little bit, good. You'll be all right. That's what learning is all about. Everything doesn't have to be easy all the time. But go ahead and stop my recording right there. Let's see, a couple of those will focus.